Good morning, everyone. It's an absolute pleasure to be here this morning as part of this three-day online conference on ocean recovery. This morning, I'm going to be talking about the Ocean Climate Nexus and nature-based solutions. And if I could sum up this presentation, it's really about a message of concern, a message of urgency, but also a message of hope, because there are things that we can do that will help us turn the corner in terms of tackling the climate change impacts we see and the biodiversity losses that we are experiencing. This is probably one of the most amazing window systems in the world. It's on the International Space Station. It's the Cupola window system. And few of us have looked through it, unlike the lucky astronauts. But when they do, we know what they see and what we would all see, which is our beautiful blue planet, finite, hanging in the dark void of space. What we know now is it's a planet, it's an ocean in trouble. And there are primary reasons why we face these challenges and the difficulties that we do. The most obvious is about the amount of carbon dioxide that we're emitting into the atmosphere. This is the levels of carbon dioxide, parts per million by volume, over the last 20,000 years. And you see on the right-hand side this distinct upturn, the Anthropocene, as some people have described it. But even a graph like this doesn't really bring home the urgency and the scale of the change that we're wreaking on the planet. Since I've been doing these presentations, I've had to add a bit to the top of the graph. So this is the current quantity of carbon dioxide in the atmosphere as measured at Hawaii. But even that doesn't bring home the scale of change during our lifetimes that we're bringing, that is driving the climatic effects that we're seeing. If you look at the amount of carbon dioxide when you were born and put that on the graph, so that's when I was born, I'm only a third of the way up that spike. So the changes that we're causing have been vast, even within my lifetime. Of course, for the ocean, the other problems are the effects that our activities have been having on the ocean. So if we compare the ocean as it used to be to as it is now, there is a repeatable formula that has run out across each ocean basin. Not completely in the same order, but broadly, starting with fishing, and then pollution, then mechanical habitat destruction, then introductions. And these have caused synergistic effects that have altered the distribution, the abundance, and the viability of ecosystems and species in the ocean, across the whole ocean now. Add to that climate change impacts, and these are having overarching effects alongside the synergistic effects. So it's almost like they're now pulling the rug underneath the management approaches that we put in place to try and deal with what would be the business as usual problems, if you like. And then, of course, just under a year ago, our world stopped. At one point, 2/3 of the world was under stay-at-home orders due to COVID-19. And I think with all the dark issues that this has brought, all the problems, all the challenges it's brought, it has also given us a time to reflect about our uneasy and too close association with nature and what that is doing to actually even threaten ourselves as a species. And there are many calls now to grow back greener, grow back smarter. So when we look at the ocean, are the things that we can do that are at that interchange between climate and biodiversity that can be beacons of hope for how we may grow back greener in the future? Well, indeed there are. There are, if you like, these nature-based solutions. And one of them, the most obvious, is about ecosystems that are particularly important for the amount of carbon that they not only capture, but they lay down. And primary amongst these have been recognized, such as species such as mangroves and, as you can see in the surrounding water, seagrass as well. And it's amazing to think that it was only about 12 years ago that I did this report. This was one of two reports that were launched in 2009 that stimulated a massive policy uptake around the world into something that's now called blue carbon. These coastal ecosystems of mangroves, salt marsh and seagrass are particularly good at capturing carbon and laying it down in a higher density than most other carbon-rich ecosystems on Earth, but they're also very threatened. So the issue is, though, that we've not made the connections between those types of ecosystem services and the ones that are working favorably for us in relation to climate issues, and how we're actually managing and protecting the very same ecosystems through marine protected areas. And we simply haven't made those connections, and we're not regulating activities in the way that we should do to ensure that the carbon processes, the natural processes that some of these ecosystems display continue well into the future. And there's good reason why we should act to do something about that now, which I'll explain a little bit later in this presentation. But as you can see from this, this slide, there's growing concern about this gap, if you like, between what we are saying we'll do to protect biodiversity, to protect ecosystem services, and what's really happening. What we have said, and we agreed as long ago as 2015 at a global scale, is we need to bring the work on conventions together. We need to be looking for that nexus. We need to be not just looking at the integration, at the connections, but also about how we integrate action in a much more meaningful manner than we have done. The good news, I said there would be good news in this presentation, is we already have policies to do this. So if we look at the outgoing policies under the Convention on Biological Diversity, if we hadn't had COVID, we might be looking at the new ones, but those, as many other processes as we know, have been delayed. If we look at the outgoing targets, we have targets which are about areas especially important for biodiversity and ecosystem services. We ought to be doing something about ecosystems that provide essential services. We ought to be doing something about ecosystem resilience and the contribution of biodiversity to carbon stocks that has been enhanced through conservation and restoration. So the issue, you can look under the Convention on Biological Diversity, you can look under a plethora of international agreements and regional agreements, and we have agreed to do these things. So the question is, what is the potential and what could we do now without really needing any more policy to make a real difference at scale in the ocean in relation to this integration of biodiversity action and climate action? Again, more good news. So I've just completed a report at the end of the year for WWF, an opinion piece, which looks at the opportunity space here, looks at the potential. And the good news is that science has moved on since 2009. And we now know there are many, many more marine ecosystems that are naturally rich in stored carbon. And they're also actually ecosystems that are often used for a reason for designation of MPAs. So the case for action becomes even stronger. So alongside seagrass and mangroves globally, we have kelp forests, we have merle beds, we have horse mussel beds, a whole plethora of biological as well as geological ecosystems that, as I say, form the bedrock, if you like, of the backbone of MPA networks around the world, where we know carbon is present in significant amounts. The issue set alongside that good news is we're running out of time. If we want to turn the corner and we want to do something to protect these habitats and to achieve recovery, we know that the trajectory that we're on, which is shown on the right-hand side of this slide, business as usual, high levels of CO2, high levels of ocean warming, acidification, deoxygenation, are going to increasingly hamper our ability to adapt, protect, and repair. And we're not quite out of time, but it's getting pretty close, and we need to take action now and build on all the existing policies and mechanisms that we have. So what could we do to significantly scale up action on blue carbon in a multi-convention agreement approach? Well, if we think of blue carbon and the Paris Agreement and agreeing to work together on all these things, and you think, and this triangle will symbolize the actions we're taking on blue carbon under the UNFCCC, when we're thinking about working under that convention, it's quite a lot about quantification of carbon sequestration and flows. And we see a focus particularly on mangroves, to a slightly lesser degree on salt marsh, and below that seagrass. And these are perhaps the order of how market ready these are to be worked on under the United Nations Climate Change Convention. And we see sort of two things happening that are mixed up together. First, about blue carbon finance and accreditation. So using that sequestration ability, that carbon ability in terms of finance markets, but also more broadly, the actions including nationally determined contributions. A whole range of countries have included these types of ecosystems as part of their nationally determined contributions. And so far, so good. But as I mentioned, time is not on our side, and it is going to take time to expand the focus of the UNFCCC to those other ecosystems that I noted earlier that are important for the carbon that they contain. But there is a massive amount that could be done now to make sure that those ecosystems are kept in good, healthy condition and restored as appropriately. So when we do get around to being able to do some action to the UNFCCC side, we at least have those ecosystems still present in reasonably healthy conditions. When I say a large amount of action that can be taken, there is a considerable amount of action that could be taken, because as I've pointed out earlier, this is about protecting the presence of known blue carbon ecosystems, ecosystem services, as part of the support mechanism for these nature-based solutions, if I can call it that. And this is about site level management action under the Convention on Biological Diversity, Ramsar, Marine World Heritage, nationally determined marine protected areas. And if you just look at the area that could be considered in this, it's 27.8 million square kilometers, or nearly 17,500 MPAs around the world can have a role to play in supporting the actions that need to both be strengthened and accelerated under the UNFCCC in support of the Paris Agreement. And what we're talking here on this part of the pyramid is things like the free-living calcareous algae called merle, biogenic reefs, oyster reefs, horse mussel beds, muds, macroalgae, other semi-stable sediments as well. And as you go down the pyramid, there's an increasing area of nature-based solution that is available for action, available within the policy space already determined, within the sites already designated. We just need to do it. And of course, when you think of the issue about carbon fluxes and flows, that is really more applicable to the UNFCCC side than to the CBD and other sides, where it's the presence that we need to be acting on. And when you look at the management regulation that would be required, so I, as part of my career, helped develop the framework, not just the regulations, but also the advice framework to implement the Habitats Directive in the UK that forms part of the way in which the conservation agencies still give advice to this day on what we need to do to protect these ecosystems in marine protected areas. So across the top, you've got the blue carbon ecosystem types, and down the side, you've got examples of categories of operations likely to cause deterioration or disturbance. Black is about the expected incompatibility between the operations down the left-hand side and the presence of blue carbon ecosystem types. And gray is incompatibility in some cases. And you can see there is a considerable case to be answered that we need to take action to protect carbon in these ecosystems as part of one of the ecosystem services in MPAs within the policy framework that we've already signed up to and we've already agreed. What are the activities likely to cause deterioration or disturbance? Well, it's activities that cause abrasion, removal, or smothering predominantly, and this involves bottom trawling, other seabed contact fisheries, and other operations that are more local scale, such as fish farms, capital dredging, dumping of dredge spoil, seabed mining, renewable energy, etc. So these are material considerations that we should already be doing and be taking action on now in marine protected areas. And I would say more broadly across the oceanscape in terms of marine spatial planning. So here is a simple 5-point plan to do the course adjustment, if I can call it that, because we've got the policies, we've got the frameworks, we've got the mechanisms, we just need to have the action. So we could recognize the full extent of blue carbon ecosystems present in MPAs. We should take action on the operations likely to cause deterioration or disturbance. For those ecosystems where we are less sure of where they are, and this may be some sediment ones in particular, I think we're quite clear on the presence of, for example, distinct features like biogenic reefs, mapping may be required. But we could also designate UMPAs based primarily on carbon values. And we should also, as I say, take measures to complement this using marine spatial planning and fisheries management measures. Enough is enough. We've come so far without doing this. This is what we should do now. So I have but one question. I have but one question for the discussions that follow. So what's stopping us? Why don't we do this now? It would be in our interest to do this now. And as the UK has now left Europe, this would be a tremendous leadership opportunity for the UK to demonstrate, both globally in terms of nationhood, but also as the up-and-coming chair of the Conference of Parties to UNFCCC later this year. Thank you very much indeed.